Welcome to NDC Porto. I'm so excited to be here opening up this incredible conference for you all. My name is Eli, and I'm here today to talk to you about how we talk to each other. So when I sat down to write this talk, I realized I'd been thinking about communication for a long time. I did some maths tutoring when I was in university, and it made me realize, as I was writing this talk, that a lot of what we do as software engineers is communicate abstract concepts, whether that's to each other, to our stakeholders, or to computers themselves. So some of the things that we run into as problems are when this communication goes wrong. So what I'm hoping to do today with you is take you through a couple of frameworks for thinking about communication and talking about some of the problems that we can sometimes have with it. So raise a hand if you've ever been in a meeting with, another team in your company, like a stakeholder, and they've said, we want you to do a thing with our software, like customers can be refunded in a different currency than the one they paid in. And you go, we're going to have to write the entire software again from scratch in order to make that work. Yeah, a few of you. Have you ever been in a code review and you've been arguing with somebody in, the comments of the PR about whether or not to use like the really elegant one-liner or the much more clear, multi-line statement, for example? Yeah, again, these are examples of when communication goes wrong. I will explain why and how that is and some ways we can try and avoid it. So, when we try and communicate ideas, here's what I think is going on. You've got two people. Here's me, and here's you. And I have an idea in my head. And in order to communicate this idea, I say something or do something, I write something. And this causes you to perceive something. But these two things are not necessarily the same. Maybe you mishear me, maybe I stumble over my words, maybe my handwriting sucks. But you perceiving something causes an idea to happen in your head. And this is the basic model of how we communicate to each other. And obviously these messages get transmitted in lots of different ways. So you might transmit messages over the internet, over a computer, or through writing things down on a page. And there's all sorts of things that can go wrong at that stage, but I'm not going to cover those too much now. But what I do like about this model is that it makes it really clear that each of these four things are different things. And at each stage where there's a translation happening, you've got chances for nuance to be lost or things to get changed in translation. This is all without even considering the complications that happen when we translate between different human languages, right? This is even happening between two native English speakers. It also makes clear that what's going on between your head and what you say is a translation layer. Like the words you say to express a concept are not equivalent to the concept itself. These two things are different. So there might be multiple ways to express an abstract concept, something I came up against when I was teaching maths, trying to explain what a logarithm is. There's lots of different ways and examples you can give, and only some of them are going to click in the brain of the person that you're trying to communicate it to. So sometimes it makes sense to try and communicate the same thing in lots of different ways. And there's also, it goes the other way, where the same word can have lots of different meanings. I don't know if any of you have seen a talk where somebody talks about, I think the word run has some of the most meanings in the English language. Like there's like 600 definitions or something. And that's a word, but it can have lots and lots of meanings. So these two things are not one-to-one, they're many-to-many, and that can get really confusing. So how can we understand the relationship between the things we think and the things we say? It is time for us to meet our first philosopher of the talk. This is Ferdinand de Saussure, and he founded modern linguistics, which is the study of language. He in particular was quite philosophical about it, so sort of philosopher of language. And the concepts that he came up with, the one that's really interesting to us today, is semiotics, which is the study of signs. And signs can mean things like road signs, visuals, but it can also mean anything we use in order to try and communicate. So a word is a sign too. And what he said was that signs have two components. The thing you are trying to convey, the idea in your head, which he called the signified, the concept being signified, and the thing that you use to signify that thing, the signifier. Now, in the interests of me not stumbling over my words and what I say being close to what you hear, I'm going to replace signified with concept, because that is a mouthful. So we have concepts and we have signifiers. And the thing that Saussure said that was really kind of radical for his time was that these two things don't actually have to have anything to do with each other intrinsically. People thought that the words we used had some kind of like intrinsic link to the concepts that they conveyed. So for example, this animal, right? In ancient Egyptian, it's called a mao. And we can kind of see where that name comes from, right? It's pretty obvious. But in English, it's a cat. And if you think about it, that word doesn't have anything to do necessarily with this animal. It's just the sounds we've decided to associate with it. The signifier doesn't really have anything to do with the concept, but because we all agree on it, it makes sense. And it gets more complex than that, right? It's not just words and road signs. We can actually assign quite complex meanings to various signifiers, right? Good memes. You can, all of these have really quite specific meanings that are conveyed precisely by these images. If you had anyone else but Steve Buscemi dressed up like that, it wouldn't have the same meaning, it wouldn't convey the same thing, right? Like, why does this picture of a frog drinking tea means someone I don't like is having a bad time and I'm trying hard not to be petty about it, but I'm kind of failing, you know? So we have this model of signifiers and things that we're trying to signify, our concepts. And we've talked about how that this layer here is actually a translation layer. But something else I like about this model is that it makes clear that these two ideas, they're not actually the same thing. Even in successful communication, the fact that that translation layer is like unique per person means that you can never be sure that the idea in your head is the same as the idea in the head of the person that you're communicating to. You can just never actually know that for sure. That's kind of scary, right? For example, we're here in Portugal. Here's a word that is commonly stated to be untranslatable. Does anyone who is Portuguese want to try and give me a translation of this word? Yeah, no, right? So we're looking at this, what does this signify and how can I understand it? How can I understand the concept that it's trying to convey, right? I can maybe never have the same idea in my head caused by this word as the idea that somebody else has in their head caused by this word. So we've got these two things. We've got concepts and we've got signifiers. We've understood that there are many concepts and that they don't necessarily have anything intrinsically to do with each other. How can we understand the relationship between these two? How do we actually get to a stage where people can communicate? Well, Saussure said that when you communicate, here's somebody with an idea in their head, and they do something to try and communicate that idea. They say something, they type something. And he called this parole, a speech act. This is an instance of you doing speech. And the reason that you know how to do this instance of speech is because you have an understanding of some broader language, the langue, which actually in French means tongue. And this understanding of this sort of broad concept that exists outside of you, it's not just contained within you, it's something that's shared between you and the people that you're trying to communicate with. This informs your ability to make acts of speech. But also, this is a circuit. Acts of speech also contribute back to the original language. So, for example, with memes, or more broadly slang, right? The reason that this image of a frog drinking tea means someone I don't like is having a bad time and I don't want to be petty about it, but I'm kind of being petty about it, is because we said so. Or, take any piece of slang. Language evolves over time. And so the parole, the act of speech, connect back to the overarching language and give us a circuit, which is what Saussure's speech circuit. So we have this idea of concepts, signifiers, people using them to make acts of speech, and that contributing to an overall sort of amorphous, shared idea of language that lets us talk to each other. So how can we understand this concept something which lives outside any one person's head, but not outside, but doesn't exist without people, something that defines and is defined by its own usage. Like, this is the thing that linguists are really interested in, right, is what is this idea that we all kind of share and all rely on and all contribute to? So it's time for us to meet our second philosopher. This is Ludwig Wittgenstein. He was active in the first half of the last century. To me, he was like the philosopher. There was nothing he didn't do, like logic, ethics, linguistics. Like, this guy did everything. Probably one of the most influential thinkers of the last century. Or maybe even of all time, according to like a lot of very smart people. And the ideas, he had like a lot of really cool ideas that I have been like immersing myself in for the last few weeks. But the one that's really interesting to us here today is the idea of language games. Now, Wittgenstein said that like games of sport or chance or skill, the way we communicate has rules that we have to obey in order to be understood. And, like games of skill or chance or athletics, these rules can differ in different circumstances. So the rules of a language game give us the means to translate between ideas in our head and things that we say or do. They provide a bridge between concepts and signifiers, and these rules are shared and understood by all players of the same language game. So you share the rules, you are able to play by the rules, and each act of speech could be understood as a move in a game, right? He didn't describe this concept very well sort of directly. He used a lot of analogies and sort of examples, so I will do the same. Let's imagine that we have two software engineers, and they are building a Lego, they're building some Lego together, right? And let's call them Dylan and Hannes, for example. And Hannes and Dylan are sitting together, and Dylan says to Hannes, "Hey, brick." And Hannes hands Dylan one of these. And then Dylan says, "Plate." And Hannes hands him one of these. And then Dylan says, "Jumper." And Hannes hands him one of these. We can see that they are playing a very primitive language game, where the rules are, if you say jumper, it means hand me one and exactly one of this specific kind of Lego element, right? Like that's it, that's the entire language game. If they said banana, it would have no meaning. That's not a move that makes sense in this language game. Now, it's worth noting, they could have used the colors of these bricks instead of the official Lego terminology for each of those elements, right? Pink has one less syllable than jumper. It would have been more efficient. However, Dylan and Hannes are enormous nerds, and they like to use the official Lego terminology. So the rules of language games that we use aren't always efficient, they aren't always logical. There is always a human element, human imprecision, human irrationality in the rules that we use to communicate with each other. So, if language has rules, what does breaking those rules look like? Here's a sentence. Take it in. This is nonsense, right? Doesn't make sense. It scans beautifully in English. It looks like it should make sense, but it doesn't. This is an example. It's called a comparative illusion, this kind of sentence. And it's like, you know that illusion of the Escher stairs where it looks like you're constantly going up, but because of the perspective, it loops back on in itself? This is kind of a linguistic parallel to that, where each element of the sentence looks like it makes sense, but when you look at it as a whole, it's like, what is that? Doesn't mean anything. So this is an example of breaking the rules of English. This just doesn't make sense. Here's another example. Can anyone guess what this means? This is something I say all the time in my household, and it means I need to trim the claws of my cat. She's the baby. She's the baby of the household. And when she gets too sharp, because she's an indoor cat, she's not wearing down her claws all the time, we need to unsharpen her. So, hey, She's getting her claws caught in, whatever she's scratching at. She's destroying our furniture. We need to unsharpen the baby. And this makes sense within my household because we all speak English, but we also play with house rules. We've got our own set of rules over and above, standard English that allow us to make non-standard moves. So, context sets the rules for a language game. This is the big thing that Wittgenstein was really trying to get at, and it was groundbreaking for his time, just like when Saussure said that signifiers and concepts didn't have to have anything to do with each other. The idea that language could mean different things in different contexts, that it didn't have some, like a set of sounds didn't have some intrinsic underlying meaning, was groundbreaking, right? That it's kind of saying the same thing, like both what Saussure said and what Wittgenstein's saying here, that things only have the meaning we assign to them. And this is obvious, but once you start really thinking about it, it leads you to be able to say things like, we need to unsharpen the baby, right? Because start really having fun with English, it's great. And it means also that without context, these sounds and signs that we try and use to communicate lose their meaning. So with this new understanding of context and rules for a language game, we can come back to looking at saudade. So my understanding of this word is that it describes a bittersweet sort of longing or wistfulness that was felt by people from Portugal as they moved to Brazil. And the sort of idea that you're leaving behind something very precious for something unknown and new and brave. And that's a very specific cultural context. And maybe other people in the past have felt very similar things. But because they were not this specific group of people with a specific cultural context, their feelings cannot meaningfully be referred to as saudade. And as somebody who doesn't have that context, doesn't have that personal history, perhaps I can never really feel a feeling that could be described as this word. So context can also be exclusionary in a very literal sense, in the sense that, if I don't have the context to understand a specific thing, maybe I just can't. So, with this in mind, what about if we have to communicate with people with whom we share very little context at all? This is a problem that we have as people, because among many of the problems we have caused for ourselves with technology, we have nuclear waste disposal and nuclear waste handling. Has anyone seen this phrase before? Oh, only a handful, right. So there is an institute for the long-term nuclear waste handling, long-term nuclear waste storage. And they have a mandate to try and figure out how we can safely store materials that are going to be deeply harmful to people for a long, long time. The half-life of some of nuclear waste that we have is on the order of tens of thousands of years, longer than any, human languages come and go much faster than that, right? And we've created a problem for people in the future that's going to outlive probably any language that we're currently using today. At least we can't assume that any language we use today is going to last that long. So how do we communicate to people of the future? Don't dig up this very specific spot. Don't do it, especially given that you say that to a human and what do? Immediately go and dig up that spot, right? And so it's a sort of a foundation made of linguists and philosophers and scientists, and they came up with a series of statements that are what they would like to they're the idea that they would like to evoke in the heads of the future people. And they're statements like, this is not a place of honor. No great deed is commemorated here. The danger here is present in your time as it was in ours. The danger is to the body. It's like the most metal series of statements. They're so cool. I want to get this on like a plaque and hang it outside my bedroom. And the idea is that these are the kind of broad statements ranging from very, very broad, this is not a place of honor, going to more specific, and the more specific we get about the things we're trying to convey, the less likely it is we'll be able to, because it requires more context. It requires us to share more rules of a language game with these people. That we can broadly assume that they will look like us. 10,000, 20,000 years is not long enough for us to undergo significant evolution, like, get more legs or anything, although depending how close you live to the nuclear waste, I mean, but if we're trying to communicate this danger to people we know nothing about, how can we actually do that? We share no context. So this institute, that's their job. They have to try and figure this problem out. Here is a diagram that they've come up with. This is ISO 21482-2007, because it was made in 2007. And this is an example of a sign that they propose putting up near nuclear waste sites. And if we look at each of these things individually, we can kind of see why this works, or why this has a good chance of working, right? So if we look at the first element, which I've said is the skull, we can assume that people in 20,000 years will have skulls similar to ours. And you never really see a skull in real life unless something's gone very wrong. So that's actually a pretty good universal symbol of, bad, you don't want to see this. It's, that's something you would never see unless something terrible has happened, right? Because we tend to bury our dead. We don't, keep them around and look at skeletons. Again, if we think about it's not long enough for us to have changed the shape of our body, this should be still recognizably a person to people in 20,000 years. And hopefully the arrow will still make sense. I mean, but run away, like move. And then the last bit is the bit that I think has the most potential to go wrong, because how do you convey the concept of nuclear radiation? It's really, really abstract and specific. So we have the nuclear radiation symbol here, and we have rays emanating. And this is visual language that we're familiar with today, but kind of don't know how it's going to translate in the future. So this is, I think, the weakest point of this communication, but it's also intrinsically very, very hard. And on the note of people thinking about, the same thing might have multiple different meanings, a friend of mine, Dylan, said that this could be described as if snakes come out of the propeller, run away from the pirates. Right? Because these signifiers to us have more than one meaning, but in the future, there are good reasons to think that this might be comprehensible to people based on very, very limited knowledge of what their context is, what rules they're going to be playing by. So this is a very extreme example, but I like it because it illustrates something that I think is intrinsic about communication between humans. All we have is best guesses, stabs in the dark, and approximations, right? Which is, again, it's kind of scary, but it is exemplified by this, I think. So there's also another angle to this particular problem, and there's a really, a story that I'm going to tell you about it, which is, how do you make sure information sticks around? What are we printing this on? Is it going to last for 10,000 years? There's an idea of data durability, the durability of a communication over time. Verbal messages get warped over time. So one person came up with an idea that I think is really funny, but also potentially, it's funny, but it's also just like this, based in very sensible ideas. So there was a guy whose name I've completely forgotten, he sort of thought, what's something that's consistent about human civilizations over the last few thousand years? We've lived with cats. We've lived with dogs too, but we've done some terrible things to them in that time. The wolves that first lived with humans however many thousands of years ago, and a chihuahua now, not recognizably the same thing. But cats, we as humans live with random bred cats that have stayed fairly consistent over time. Human companionship with cats is something we can reasonably expect to continue arbitrarily into the future, right? And this guy said, okay, we have the technology using genetic techniques, genetic manipulation, to breed cats that glow in the dark in response to radioactive emissions, right? I want one so badly, so badly. And he said, okay, so now we have a visual marker of a change, right? But how do we communicate to these humans 10,000, 20,000 years in the future that this change is bad and that they need to leave, right? And he said, okay, what's a way that information has been passed down without much change over time? And he said, music. right? Folk songs, folklore, music. He said we need to instill a folklore tradition of cats that change color being a bad omen. And to this end, he wrote a song called Don't Change Color, Kitty. And apparently it's so catchy that it's like it would last 10,000 years. I have not listened to it because I don't want my life to be ruined forever. So I have no idea if it actually is that catchy, right? But his idea was that music can be used to carry a very specific cultural message. And after all, we're no strangers to love. Or the idea that music can be used to carry a very specific cultural message, right? Such as, ha, gotcha. Right. One last meme for the road while I grab a drink of water. All right. So we've come to the idea that we've got, this is how humans communicate, and it's all based on context, and sometimes we have very little context, although unless you're working at that long-term nuclear waste storage facility, and if you are, please come forward, oh my gosh. The mandate ends they have until 2033 to figure out, what are they gonna do, and how are we gonna try and communicate these things, so if we're still all around there, I guess we'll see what they come up with. But unless you're working in a long-term nuclear waste storage facility, and the teams that are trying to communicate about that, we can assume that we share quite a lot of context, and our ways that we communicate are easier than having to write songs called Don't Change Color, Kitty. However, we are engineers and designers and builders of software. What does all this mean for us? This is all great, we're communicating with people. But actually, a lot of what we do in our jobs day to day is this. We're trying to talk to a computer. You have an idea in the head, you write some code, and the computer runs it. You've got a thing that you want done, and you're trying to communicate that thing to the computer so it can do it for you. But how can we talk to a computer? It intrinsically has no concept of any of the things we've been talking about, right? It doesn't speak English, it doesn't speak any language necessarily. Well, we design our own languages. We start with machine code and we add abstractions and syntactic sugar, layer and layer and layer until we have something we can reasonably call a programming language. Programming languages are a set of rules for language games. We can define our own languages by teaching our computers what signifiers like if and when and open curly braces actually mean. And just like different language games have different rules and different contexts, these things mean different things in different programming languages. And when you have a transpiler, that's doing translation. So, in this model, where the first half is very similar to what we're doing when we communicate with a computer or with a person, right? This bit is a solved problem. We can actually understand, if I write some Python code and I'm running in C Python, I know what's going on at the C level, and I know how that translates into machine code because I can look at the compiler. So I can actually understand exactly what's going on from the Python code down to what the computer executes. In theory, it's a lot of work, but it can be done. So this part, in theory, is a solved problem. And a lot of what we have to do in order to make this communication better and easier is this part. Get better at writing code. Get better at framing our ideas, making the translation layer between what's in our head and what we write as code that machine operates on is as seamless as possible and involves the least translation possible, right? On a side note, this is why prompt engineering is qualitatively different than writing code, is because prompt engineering brings a black box back into this side of the diagram. It means that you cannot understand exactly what's going on at each level of the stack. So I think that's the real interesting bit of AI and machine learning is it changes the actual mechanics of what's going on when we use computers. Obviously doing things better, faster, having applied statistics is great, but that's, I think, something that's not many people are talking about, and it's really cool. So we have this paradigm where you're talking to a computer and you're alone in your bedroom, hacking on something, making a little video game, making a website, whatever. And this is great, and you get really, really good at translating your ideas into code. But actually, when you get a job as a software engineer, what's going on is this. You're talking to the computer, and so is someone else, software engineer on your team. And they have their own ideas and their code that they write. And you have to communicate with each other in order to make sure that you are doing the right thing. You have to communicate with each other to make sure that the ideas you have in this head, in each of your heads, are as aligned as possible in the knowledge that you can never actually know that. And so that you have as few merge conflicts as possible, as few, team crunch time because you realize that you were building the wrong thing. So we have to communicate with the computers, and we also have to communicate with each other. So all of this stuff about talking to people is very directly relevant to us too. Make sure you mean the same thing when you say the word run, And so this arrow at the bottom, it's things like meetings, it's things like documentation, it's water cooler chat. It's sometimes also comments in your code, right? Because those aren't executed by the computer. Those are very specifically for communicating with other humans. So commenting your code, documentation, these are all crucial parts of the coding process when you're coding with other people. They're not just nice to have, they are essential. So when we think about the communication that happens between us and the communication that happens between us via the computer, we start to see that there are two, like you've got this direct arrow here, but actually that path at the top is also a method of communication between the two people. You are communicating with each other through the code as well as alongside the code. Like code is, when you're writing code collaboratively, also a method of communication between you and the people on your team. So how do we do that well? How do we write code that communicates as well as that's able to be operated on by a machine? It's time for us to meet our last philosopher of the talk. This is a guy called Paul Grice. He was a British philosopher of language. And the thing that he came up with that's interesting to us today is the idea of the cooperative principle. And what he meant by this is the idea that when you're communicating cooperatively with somebody, there are some rules that he noticed tend to arise in those kinds of communications. And what he meant by cooperatively is you're not telling a joke, you're not lying, you're not trying to manipulate somebody, you are genuinely working together to do, in the best faith possible, the process of getting an idea from one person's head to another and bring your ideas into alignment. And what he noticed was that there are four sort of categories of rules, four things that he noticed came up again and again and again in these kinds of communications as he observed them. And they are called Grice's maxims. So the first one is the maxim of quantity. When you're communicating cooperatively, you should include all the information that's necessary, don't leave things out, but also don't give too much. Don't info dump too much. Don't include stuff that's not actually relevant. The second one is the maxim of truth. Don't lie, right? If you're communicating cooperatively, don't say things that you don't believe to be true, reasonably believe to be true. Like, it's okay not to be 100% sure of something, because as we've talked about, you can never be 100% sure what's in someone else's head. So does that mean you just don't speculate about what somebody else might believe, even if they've told you themselves? No, stuff that you reasonably believe to be true is fine here. So the maxim of truth, don't lie. You've got the maxim of relevance, and this ties into the maxim of quantity, right? Only talk about things that are actually relevant to the situation at hand. So, if Dylan and Hannah are playing their Lego game, and Dylan says jumper, and Hannah hands him a page that's opened to the definition of the jumper Lego element on like the Lego Wikipedia page or whatever, that's not relevant necessarily. Well, it's not relevant. It's breaking the rules of their language game. So keep things relevant. The maxim of clarity, which is don't use big thesaurus words. Say what you mean as clearly as possible in a way that is designed to be understandable by the person you're communicating with. And this is the one that requires like empathy, because it requires you to understand what is going to be understandable by the person or people with whom you're communicating. This one I absolutely love, because Grice gave sort of single word summaries of each of these. So maxim of quantity, like be informative. Maxim of truth, be truthful. Maxim of relevance, be relevant. The maxim of clarity, he didn't say be clear, he said be perspicuous. Has anyone heard that word before? A couple. Yeah, I hadn't. I had to go and look it up. So yeah, completely breaking his own rule there. Be perspicuous. If you ever need, I don't know, just like a fun fact about yourself, oh, icebreaker, tell me a fun fact about yourself. Just say, I'm perspicuous. Ridiculous word. Anyway, so these are some maxims that Grice noted tend to come up again and again as sort of guidelines for how to communicate cooperatively. When we're thinking about communication through code, these actually translate really nicely into ways to write code, right? So maxim of quantity, where B is informative as required, not more, turns into like, make sure that the code you have actually solves the problem that you have. Like make sure that the code is answering the question. Make sure that your data structures have everything you need. So I used to work as a data engineer, so I've done some data modeling. And we had this really long-running study. It was a biotech company. And it's like basically a breathalyzer for disease. And the long-running study we had was for lung cancer. And we did clinical trials. We collected lots and lots of data from people like, do you smoke? How old are you? Do you have any allergies? So on and so forth. And then we analyzed their breath and saw if we could detect markers of lung cancer. Does anyone want to guess what information we did not record from the patients of this clinical trial? Do you have lung cancer? We didn't record it. So make sure you do, make sure you're getting the information that you need and that it's present in all parts of your system and your code. Scoping your code appropriately. Don't be more informative in a function than is required. Don't make your functions enormous, like massive mega functions, right? And again, this one ties into the maxim of relevance. They're very, very closely related. Maxim of truth. Only say things you know. So validate your assumptions in code. If you assume that a certain field is present, check that. If you assume that certain things are going to be equal to certain things, check that. Don't write code that you don't reasonably believe can run. Obviously, there's a certain point where it's like, sometimes your code just won't compile, and that's great. We love it when things get caught early. But yeah, validate your assumptions. This also comes back to the out-of-band communication, where it's like, if I'm going to make an assumption that a certain piece of information is going to be available to me in the database, check with the people who put it there. Is that fair? Is that a fair assumption? But yeah, throwing errors when things aren't as expected. Don't fail silently. So don't pretend things are fine when they aren't. Don't go, oh, I guess it's probably fine. No, if you can't reasonably believe that things are fine, throw an error. Maximum of relevance. Don't include things that aren't relevant. Factoring out separate use cases. We all love refactoring, right? We love clean code. We love readable code. Avoiding big mega functions. So you're looking for one particular use case, and you have to scroll past 1,000 lines of things that happen to come in through the same entry point but have got nothing to do with it. Don't have unused variables. This is kind of an obvious one. Maximum of clarity. Being perspicuous. Clean code. Obviously, focus on readability, not elegance. So coming back to the idea of, you're in your code review and you're like, someone's going, oh, but you could do this in one line with a list comprehension and a this and that and a mapping, and I'm going to import collections and I'm going to define my own function, whatever, or define my own meta type or something like that. Focus on readability. We all know this. Your code is going to be read more than it's going to be written. When you're trying to communicate through code, you're trying to communicate both to a computer, but also to another person. So focus on readability. And the last one is the one that I really want to talk about. And this is about matching your code structure to the structure of the problem it solves, right? If you've got a problem and you want to clearly communicate about that problem, don't turn it into make sure that your data models match what you're actually talking about, the problem that you're really trying to solve. This is the clearest way to talk about the problem that you're trying to solve through code. This is DDD. This is domain-driven design, basically. So when we're talking about building software collaboratively on a team, we've got this situation where, there's you and there's the other members of your team, and you're building code together and you're talking together about what needs to be done, and you've got your Jira boards, and you've got your meetings, and you've got your code reviews, and this is all nice and happy, and you may have disagreements about whether or not the one-liner or the readability is better, but by and large, if we were left to ourselves, this is also getting towards a solved problem, right? Unfortunately, stakeholders. We have stakeholders, and they have ideas, and they communicate them to us. And this is what's really happening in software engineering. They communicate them to us verbally, through emails, through communicating to your project manager. And that causes you, the project manager, to come around and tell you something. So you perceive something, you hear something, you're in the all hands, and they say, we're going to build AI into our projects. And then you have an idea in your head of what needs to be done as a result. You've got your Jira tickets, you have the ideas within the team of what needs doing, that's the blue light bulb, and you communicate those to the computer, right? So this is what's really going on in software engineering, is it's not just our ideas about what needs doing, it's our stakeholders' ideas. And they don't speak computer. They just know the problem that needs to be solved. But what stakeholders think is going on is there's them, and they make things happen on the computer. They say words, and software appears. We are an implementation detail, right? So what we are in this model is the translation layer between what's in the stakeholder's head and what the computer does. And the work of doing translation is much, much easier when we can do less work, when what's on the computer matches what's in the stakeholders' heads, like the real problems that they are trying to solve. So we model domains as they actually exist in reality. We try and do as little abstraction as possible when we talk to the computer. And this avoids the problem, or it can mitigate the problem where your stakeholder comes and says, we need to refund customers in a different currency than what they originally paid. And you go, we have to rewrite from scratch. But actually, if the way that your computer thinks about the world, the way that your software thinks about the world, is closely aligned to the way that your stakeholders think about the world, you're going to have fewer instances where they have a fundamental inability to communicate, which is what's happening when you say we need to rewrite from scratch. So, domain-driven design, it's great. We need to make our own lives easier as developers, as the translation layer between the people who pay our bills and the work that we do. And what this looks like, what domain-driven design kind of comes down to in the language of the talk that I've just been giving to you all, is this. It's about reusing context. It's about taking the context from what your stakeholders are giving you, saying this is the real world situation that this code operates in, that this software operates in. Taking that context and using that context as the rules for the language game you play with the computer. So earlier I mentioned that a programming language sets the rules for a language game. But actually, it's got a few more layers than that, because when you write modules, you're introducing new rules. When you write software, which is built up of these modules and the ways that they function, you're adding new rules into that language game that you play with your computer. And when you rewrite from scratch, you're stripping all those rules back to the base layer of the programming language, right? Or the framework, and so on. So we are, as software developers, building up language, very specific contextual language with which we can talk to the computer. And that's what we do as software engineers, is we build languages. And so when we need to build a language, we need context. And our work is made easier when the context that we use is the context of the people who are paying our bills. This means that we're basically all playing the same language game. It allows us to do things like have stakeholders write tests in behavior-driven design languages like Gherkin, and for us to do minimal work into turning those into things that the computer can operate on. And we facilitate the communication between the stakeholder and the computer. It means that we don't have to spend effort translating. It means that our work is easier and we can get to the results faster and have more time off to play Starfield. And it means that our signifiers more closely match our concepts, so that we don't have to spend effort on that translation layer in our heads. When our stakeholders say user, we know what that means because we have agreed that we are sharing the same context, and our computer agrees that that's the same thing. And so it's not going to throw a hissy fit when we say they need to be refunded in a different currency. So, conclusions. A lot of what I've been talking about in this talk today is pretty abstract, right? And it's hard to communicate succinctly. So these conclusions are, more what I've tried to do today is put some ideas into your head, even if I can never know what they are perfectly, to try and put some ideas into your head, get some wheels turning, get you warmed up for the rest of this conference. But there are a few things that I hope you take away with you, and they are these. Computers are awesome, right? Hey, computers are awesome. We can talk to them in ways that are qualitatively different than the way we talk to people. That feeling of like, yes, I got it to work, right? because you know that what you've done is you've communicated perfectly with the computer. You've got the idea, the code that fits in your head, and you made the computer understand it. That's amazing. Like the fact that we can do that, that's genuinely awesome. On a philosophical level, that's awesome, right? We can know that we've been understood. Communication is hard, like communicating with people, other software engineers, stakeholders, and computers. Like, it is difficult. We should be proud of ourselves for being able to do any of it at all. Everyone give yourself a pat on the back for being able to talk to people. It's hard, right? Yep, pat on the back. But you can get better at it, like with a little thought, a little empathy, a little understanding of what somebody else's context is, so that you can play the language game better with them, better and more effectively. It can make the lives of us and everyone around us a little bit easier. That's really good. Like, you know, that's worth putting in a little time, a little empathy. Maybe you don't have to read quite as much philosophy as I did to write this talk. But it really can make your life a lot easier, save you a lot of trouble down the road, helps you in all areas of your life, but in your job in particular, I think. Thank you for coming with me on this journey through linguistics and philosophy. I hope you've enjoyed it, and I cannot wait to share the rest of this conference with you.